One of the great things about living in most parts of the United States is that you can go to your kitchen, turn on your faucet, and have immediate access to good drinking water. We often take this for granted, but you should realize that many places in the world don't have good drinking water piped to every household. Today I want to talk about federal water regulations. Because there's so many uses for water, and therefore many different regulations, I'll mostly focus on drinking water. After today, you should know the types of water that is regulated, some common pollutants found in drinking water, how to access the federal drinking water standards, the difference between primary and secondary drinking water standards, and some other nomenclature, and the overarching categories of drinking water pollutants. Now, as a secondary note, you can also use the information to gain some knowledge of what is considered a large or small quantity of contaminant in a water body or in drinking water. First, there are many types of water standards. Separate regulations exist for different water types. For example, drinking water, water bodies used for recreation, and wastewater all have different regulations and guidelines governing them. While a contaminant may be a perfectly fine concentration for recreation, like in a lake, that contaminant level may be too high for drinking. Regulated water falls under the Clean Water Act and the Safe Drinking Water Act. The Clean Water Act regulates pollutant discharges into water bodies and establishes water quality standards for surface water. Discharges into surface water bodies require a permit, which falls under the National Pollutant Discharge Elimination System, or NPDES. Wastewater, stormwater, and agricultural discharges all fall under the NPDES. These permits are publicly available, and you can search for permits issued in your area. Water quality standards for surface water bodies are established federally or by the states. For example, Montana's water quality standards are published in circulars DEQ 7, DEQ 12A, and DEQ 12B. So you can look those up. If you're curious about your local waterways, you can also use the EPA How's My Water app. Here, just for an example, I've pulled up one watershed in Butte that contains Silverbow Creek. You can see that the creek is listed as impaired due to high levels of mercury, metals, and nutrients. It also has high sediments and a degraded habitat. Explore surface water quality near your home. How are the waterways? As you work surface water problems in this class and others, you can always reference surface water quality standards to see if your answers are within the expected range for a given contaminant. The Safe Drinking Water Act is what governs drinking water in the United States. It includes standards for nearly 100 contaminants. These standards apply only to public water systems, not private wells. If you happen to own a private well, it's your personal responsibility to test the water and make sure it is good enough to drink. When you're looking at drinking water standards, you'll see both primary and secondary standards. Primary drinking water standards protect public health and they're enforceable. These standards fall into 6 main categories: microorganisms, disinfectants, disinfection byproducts, inorganic chemicals, organic chemicals, and radionuclides. Microorganisms include protozoa like Cryptosporidium and Giardia, bacteria like Legionella and E. coli, and viruses. When you look at primary drinking water standards, you'll notice a few things. First, you'll see the contaminant listed. Some of these contaminants are linked to pages with additional information. Next, we have the MCLG, which is the maximum contaminant level goal. This is a non-enforceable goal at which no known health risk exists. They also include a margin of safety. In a perfect world where economics is not a factor, all drinking water would meet the MCLGs. The maximum contaminant level, MCL, is the highest level allowed. This is the enforceable standard. Normally, this would be higher than the MCLG because it takes economics and technology costs into account. In some cases, measuring the contaminant is difficult, so public water supplies must meet a standard for a treatment technique, or TT. So in this first set of rules for microorganisms, you can see that we want 0 cryptosporidium and giardia. However, measuring those is difficult, especially to such a low level. So all public water systems must meet a certain treatment technology. For each contaminant, you can follow the footnote here to find the specific treatment technology required. If you look further down this table, you'll see the health effects and the common sources of each contaminant. Our next group of drinking water contaminants are disinfectants. In the US, all drinking water is disinfected with chlorine. Chlorine is favored because residual chlorine remains in the water once it leaves the water treatment plant and enters the distribution system. Therefore, it can protect against recontamination if you have a leak in the pipe. In these standards, you see the MRDL, which is the maximum residual disinfectant level. So at this level, water has sufficient residual to prevent reintroduction of harmful bacteria. However, at this level, water has sufficient residual to prevent growth of harmful bacteria. However, the water may also have health effects as well. Residual disinfectant levels are therefore a balancing act, and the benefits of protection against microorganisms is weighted against the cost of the negative health effects. One of the main issues with chlorine disinfectants is the formation of disinfection byproducts, which is our third category of contaminants. These byproducts form as a result of chlorine compounds reacting with natural compounds present in water. Some of these compounds are carcinogenic, and their formation can be a big issue. In fact, the relatively recent upgrade to Basin Creek Water Treatment Plant in Butte was due to trouble meeting regulations regarding disinfection byproducts. Then we have inorganic chemicals. These include heavy metals, nanomaterials like asbestos, and fertilizer residues. If you scroll down, you'll see nitrate measured as nitrogen. We'll talk about this unit when we discuss water units pretty soon. Next, there are organic chemicals. I know you often see the word organic referring to food grown without pesticides, etc., but we're not talking about kale. This refers to compounds containing carbon and hydrogen. That's the chemistry definition. Organic compounds can include herbicides, insecticides, and chemicals found in industrial discharges. Finally, we have radionuclides. Often radionuclides are naturally occurring, and they can present a problem for drinking water, and they're even a bigger issue for indoor air quality, especially in some places, including Butte. The EPA also has set non-mandatory guidelines for 15 contaminants. These are the secondary drinking water standards, and they address aesthetic concerns including taste, color, odor, and cosmetic effects. At the secondary maximum contaminant level, or the SMCL, these contaminants do not present a human health risk. Therefore, exceeding the SMCL may result in water that doesn't look or taste very good, but it's not necessarily going to hurt you. You can find the secondary standards and their noticeable effects on the EPA's webpage. That concludes my very brief overview of water regulations. This is really just the tip of the iceberg, and I encourage you to look into it further. And you will have to look into it further in other classes. You can use the links provided to see what issues exist where you live. You can also use the federal or state water guidelines as a benchmark for any concentrations you encounter. If you're not sure, for example, if 5 milligrams per liter of something is high, then look up the regulation for it, and that's going to give you a much better idea. To recap, you should now know the types of water that's regulated. some common pollutants found in drinking water, how to access the federal drinking water standards, the difference between primary and secondary water standards, and some nomenclature, and some of the overarching categories of drinking water pollutants.